All right, ladies and gentlemen, welcome to unit number 6. We are almost done with the fall semester. We've got a couple of weeks till Christmas. Yay, Christmas time and Christmas break. Ladies and gentlemen, we are going to be talking about systems in unit 6, systems of linear equations and systems of inequalities. And all a system is one or more, actually more, two or more lines that are related to each other, or two or more inequalities that are related to each other. So in this system of equations, this x, the independent variable, is the same, and the outputs, the dependent variables, are the same. It's the same variable. Now, that doesn't mean a whole lot when we just have just regular equations like this, but when we get to word problems, next class, it'll become a little bit more clear. These are exactly the same thing, and these are exactly the same thing. So you remember from 8th grade that when we have a system of equations, we are looking for the intersection point. The solution is the intersection point. So when we have a system of equations, and I'm just going to write EQ for equations, a solution is the intersection. So this word solution gets used a lot in math class. When we just got done working on inequalities, and the solution of an inequality is the shaded space. But when we're dealing with system of equations, when we're dealing with two or more lines, the solution is the intersection. So we can take this and we can graph it very easily on this graph, and we can find the intersection point. And again, this part should be familiar to you. This is 8th grade. So let's take equation number 1, y-intercept of 3. This is rise over run. And I always tend to put this negative with the numerator. So negative 5, 1, 2, 3, 4, 5. Positive 3, 1, 2, 3, rise over run. I'm going to take my handy-dandy ruler. I've plotted points, and now I'm going to graph my line. Plot points, graph your line. Plot points, graph your line. So there's the first line. And now let's get the second line. So we've got negative 3, y-intercept of negative 3, which is right here. Rise 1, run 3, rise 1, 1, 2, 3. Oh, look at that. That's the intersection point. Now let me graph this line. Nice and straight. And the intersection point is 1, 2, 3, negative 1, 2. So the intersection point is 3, negative 2. So that's the answer. But I want us to learn how to do it graphically. I want us to remember how to do it graphically from 8th grade. And let's do it algebraically. Let me see if I can get all of that in the screen. There we go. We can do this algebraically. Now, something I want you to remember, it says substitute and solve. Something I want you to remember from unit number 3, and something that I want you to remember just from middle school or even elementary school. Let's talk about two things for a second. What is 6 plus 1? 6 plus 1 equals 7. Fantastic. Well done, ladies and gentlemen. 3 plus 4 equals what? Hey, that's right. It's 7. Well, guess what? Guess what equals itself? 7. That's true, right? 7 equals 7. Well, look what also is true. 6 plus 1 equals 7, and 3 plus 4 equals 7. Well, if that's true, then since all of this equals each other, 6 plus 1 equals 3 plus 4. 7 equals 7. It's exactly the same. This is just basic math. It's all about equalities, things that equal each other. All right, so if this equals each other, look what we can do with this. Y's. That's kind of like these 7s right here. This equation equals 7, this equation equals 7, this equation equals y, this equation equals y. So guess what is equal to each other? Y equals y, because it's the same thing. And if y equals y, then this right-hand side of the equation equals this right-hand side of the equation. And what I can do is I can substitute. I can say that this y, which is the same as this y, is really this. So I can say negative 5 over 3 plus 3 equals, oh, I'm sorry, I forgot the x. Man, just like a student in 9th grade forgets the x. Happens to everybody. So usually I catch my mistakes. So the left hand, this right here equals this right here. So the right-hand side of the first equation equals the right-hand side of the second equation, which allows me, I'm substituting the y's, which allows me to have something that looks very much like what we did in the third unit. We're going to solve for x by collecting like terms, solving for 0 or making 0 and making 1. So right here, we're going to make 0. We're going to make 0 here, so I need to subtract 3. Subtract 3. Drop this down. Equals 1/3 x. Negative 3 minus 3 is negative 6. And now I need to make 0 right here. Negative 1/3 x minus 1/3 x. Negative 5 minus 1 is negative 6. I'm going to write that right here. Negative 6 over 3x equals negative 6. Negative 6 divided by 3 is negative 2x equals negative 6. And then right here we've got negative, we need to make 1. We need to make 1. So we are going to divide by negative 2. Divide by negative 2. So if I do it on one side, I got to do it on the other side. That becomes 1. X equals, negative and a negative make a positive. 6 divided by 2 is 3. Look. That's supposed to be a, I don't know where that line right there came from, but certainly not our, positive 3 is the x-coordinate. Positive 3 is the x-coordinate. Well, how do we get the y-coordinate? Well, we are going to substitute. So we're going to take either one of the equations. It doesn't matter. Let's take the bottom one. We're going to say y equals 1/3 x minus 3. Well, our x is 3. 1/3 times 3 is 1. You can use your calculator for that if you're not sure how to make that work. 1 minus 3, y equals negative 2. Oh, look at that. We have an x value of 3, a y value of negative 2, and our solution is 3 minus 2. Now, we can also do this on the calculator by verifying what we got, just like we did in unit number 3. We can take the two equations. This will be y1, this will be y2. So we've got negative 5/3, close parentheses, x plus 3. And we're going to drop this down to y2. We're going to put in the second equation right here. So we've got parentheses, 1 divided by 3, close parentheses, x minus 3, and now we're going to graph it. We see the intersection point right here. Second, oh, let me get out of this glare, sorry about that. Second trace, let me pull this up just a little higher. Second trace, second calc, and we're going to come down to intersect, because we want to find the intersection. Enter. Is this the first curve? Look at your calculator. First curve, is this the line that we want? Yeah, that's fine. Second curve is the second line. That's fine. And then do we want to guess? No. And then the intersection point's right here. Negative 3, 2. And that's what this blank is for. You're a teacher, and your classroom might do it a little bit differently. What I'm going to do is I'm going to ask each student to show me this calculator screen. And then when I see this calculator screen, and then when it comes up with the correct answer, what they have mathematically and they have graphically, I'm going to sign off on that with my initials. It doesn't really look like that. My initials end up being a squiggle when I'm going really fast. So there you are. That's how we're going to do these problems. You're going to do them graphically. We're going to substitute and solve, and we're going to find x. Then you're going to take this value and substitute it again into one of the equations, and you're going to simplify and solve for both the x-coordinate and the y-coordinate. It should match your graph, and it should match your calculator.